Section 3.1, solve a system of linear equations by graphing. And for now, we're only going to deal with two equations in our system. In real life, there's usually lots of different systems of variables that create a pretty complex system. So there are three scenarios that can happen when we have two lines. They might intersect, they might be parallel, or they might be the same line. What happens in each of these cases, or why is this the case? So if they only intersect once, they have one solution. There is only one point that makes both equations true. When does this happen? When they have different slopes, they intersect. When are they parallel? When they're parallel, there's no solution. There is no point that they share. In order to be parallel, they must have the same slope but different y-intercepts. And finally, what's going on here is we can only see one line because essentially the system is the same line. And in that case, there are infinite solutions because every point they share. And that might look something like this. Y equals 3x minus 4. If every term was just multiplied by 3, in the end you'd get the same set of points and you'd have the same line. In this section, you're going to be working with two familiar forms of linear equations. You have the slope-intercept form, y equals mx plus b, and you have the standard form, ax plus by equals c. They might look something like this, y equals 4x minus 2, or 3x minus 4y equals 12. So we're solving systems by graphing. We're trying to first see if they have an intersection and then determine what that intersection is. So the example I'm going to use are these two lines. X minus 2y equals 4 and 4x plus 2y equals 6. If the numbers are nice, a convenient way to graph an equation in standard form is to find each intercept. So if I want to find the y-intercept, we're pretty familiar with that. I said x equal to 0, and if negative 2y equals 4, then y must equal negative 2. And now I'm going to find the x-intercept and let y be 0, and what do I get? X equals 4. So there's my 2 points, 0, negative 2, and 4, comma 0. And there's my line. We won't be doing a lot of this by hand because there's so many things you have to get so right. And trying to find an intersection of two lines on graph paper isn't always easy. But it's good practice in terms of graphing and rearranging the equation. So, for example, to find the x and y intercepts up here, it's not as neat and tidy. If I let x be 0, that's pretty easy, y is 3. If I let y be 0, I get a funky number like 3/2. So what I might then do is rearrange this equation. So I'm going to subtract 4x from both sides, and I'll write it in mx plus b form. It's not entirely necessary. So 2y equals negative 4x plus 6. And then if I divide that by 2, I need to divide every term by 2. And I get y equals negative 2x plus 3. And if I make a table of values for that, we just work this one out. If x is 0, y will be 3. And then I might pick another number somewhere further down the line and say, well, what if x is 2? 2 times negative 2 is negative 4, plus 3 is negative 1. So it was 0, 1, 2, 3, 2, negative 1. Graph that. So here's the equation, 4x plus 2y equals 6. Always label your lines with the equation. And it appears that they are intersecting at 2, negative 1. So if I were to check that algebraically, I would plug 2, negative 1 into the equation and see if it checks. 2 plus 2 is 4, check. 4 times 2 plus 2 times negative 1 equals 6. Yes, 8 minus 2 equals 6. That checks. I'd also like to show you how to do this in your calculator, and I've uploaded a video to show you how to do it on GeoGebra. because when things get a little more complicated, I mean, this is essentially how we're going to do it. So let's go back to this equation. X minus 2y equals 4. So it's not, I have to get y by itself. So what's the first thing I would do? Got to use parentheses. 4, I'm going to subtract x from both sides, right? And then I would have to divide by negative 2. So there's that equation. And then this other one is 6, so I'm going to start with 6. And I would have to subtract 4x. And then I would need to divide by positive 2. And so I like to usually zoom 6. A lot of the stuff we're working with, usually you can see in a standard window, so zoom 6 just gives us negative 10 to positive 10 on both axes. And if I want to know where this intersection is, I want to use this calc function above trace. So to do that, I have to hit second calc, and notice number 5 is intersect. You can cursor down to it or just press 5. And it's going to ask you what curve or lines it's looking for, because you might have 5 on there. So is that your first curve? You say yes. It says, is this the second one? You say yes. And then, oh, somehow I skipped the guess. I must have hit the trigger, but it usually says guess, and then I just hit enter, and then it's telling me my intersection is 2, negative 1. So I also confirmed that by technology. So you should be able to complete the few of those with relative ease. Good practice rearranging equations, good practice making a table of values, good practice graphing and checking.